First we will describe why the sky is blue during the day. This is due to the Rayleigh scattering law, which states that when light is scattered from particles that have a refractive index different from that of the surrounding medium and have dimensions considerably smaller than the wavelength, the scattered intensity is proportional to the incident intensity, to the square of the volume of the scattering particle, and inversely proportional to the fourth power of the wavelength of the light. The short wavelengths blue and violet are scattered by molecules in the air much more than other colors of the spectrum. This is why blue and violet light reach our eyes from all directions on a clear day. But because we can't see violet very well, the sky appears blue. Air molecules are much smaller than 400 to 700 nanometers, about 1,000 times smaller. Thus, air is a good Rayleigh scatterer. If it weren't for our eyes being more sensitive to blue light, selective scattering would make a clear sky appear violet. The sunsets and sunrises vary in different parts of the world or with certain times of the year. Is it due to pollution? Pollution actually has a negative effect on the intensity of a sunrise or sunset. Typical pollution droplets, such as those found in urban smog or summertime haze, are much larger than the air molecules, so they do not make good Rayleigh scatterers. This gives the sky a grayish or white haze. Clean air is, in fact, the main ingredient common to brightly colored sunrises and sunsets. Eye-catching sunrises and sunsets also seem to favor certain times of the year. In the middle latitudes and over the eastern half of the United States, for example, fall and winter generally produce the most spectacular low sun hues. Density gradients in the atmosphere cause it to act like a lens. Rays bend towards the higher density. Higher density is associated with higher pressure and lower temperature, so a useful guideline for atmospheric refraction is that rays bend towards higher pressure and to cooler air. Incoming rays from the sun curve downwards, so that it appears higher in the sky than it really is. The effect is small except near the horizon when the rays are literally bent around the curve of the Earth. When the lower edge of the sun just touches the horizon, the whole sun has actually already set. Objects close to the horizon are raised upward the most, and the lower edge of the sun is raised more than the top, making it appear oval.
At sunrise or sunset, the rays coming from the sun strike the surface of the earth at a low angle. These rays must pass through much more atmosphere than at any other time of the day. The atmosphere thickness that rays from the sun travel through is about 12 times longer at sunrise or sunset than it is at midday. The thicker atmosphere path results in a greater scattering of shorter wavelengths by the air molecules present. And because red has the longest wavelength of any visible light, the sun is red when it's on the horizon, when its extremely long path through the atmosphere blocks all other colors.